Hello and welcome to another lecture in Administration of Operating Systems course. Today we will continue talking about bash scripting. So as a short reminder, bash scripts are regular text file. Those are things that you create with text editor, so having a good one is useful. And you basically put one command per line. And this is what gets executed one by one, except in cases where you have more complicated control structures, such as the for loop, which we have talked about last lecture, or other kinds of loops or if statements that we will be talking about today. The important aspect of scripting is the debugging, so you want to make sure that your programs work properly, and typically they don't at the beginning, so you have to figure out what is wrong, and you want to use debugging for that. So -x option to the bash is pretty useful, and it's important to distinguish between syntax problems and logic problems. And typically, in most cases, the syntax problems are things that computer will at least to some degree help you find, because it will most often complain that it doesn't understand a particular statement, and then you can just figure out what have you written and what you should have wrote and fix your mistakes. Now, the logic problems are harder because those are things that you didn't properly specify what you really want to do. What you have specified is probably possible to do, but it doesn't give the results that you are looking for. And figuring out why that's the case is often much more complicated. So there are different ways of running scripts. The most basic one is where you type bash and then script name. But if the script is executable, you can also just execute the script and let the Linux system figure out what kind of programming language is this script supposed to be using. Besides the scripting itself, you are supposed to use all the commands that you have learned until now, but here are a couple more that are especially useful within scripts. So they are much less useful interactively. They are important when you are trying to combine different things in order to get more interesting results. So for example, tr allows you to translate or delete characters. So when you want to change, for example, or a's into b's, or change or dots into commas, things like that, this is the tool that is very useful. Cut you have probably used to some degree, at least on the labs. It allows you to remove sections from each line of files. So you can say that you are only interested in the first 5 characters of each line, or in characters 7, 13, and 25, or something like this. And you can also do it not only based on the character numbers, but you can also, if the structure of the line is reasonably consistent, for example, like etc password, it has fields, so you can tell cat that you are only interested in first and second fields of those. You have to specify what's the delimiting character between those fields, but after you do that, you can just access individual fields. BC stands for the basic calculator, and you can do calculations in it, including with real numbers. So that can be useful in a number of situations. Xargs is something you have already worked with, but again, it's not something you would use very often on the interactive command line, although sometimes you can, but it's significantly more important in scripting. And finally, if you want to do some kind of text processing or edit text, what you could use is sed. Sed is very complex. It's called stream editor. So it's a full-fledged editor, except you don't have all the text displayed on the screen at the same time. You can think of sed as a kind of filter which analyzes text as it passes through and modifies things. So typically you will not really need the full power of sed, but if you are interested in that, there are some really cool things that you can do to text using sed. But those are just the new ones. All the commands that you have already known are still going to be useful in writing scripts. And similarly, the idea of combining them with pipes, with input and output redirections, and so on, is also something that you always have to keep in mind because it will be useful in solving problems. So last time we have looked at the for loop, which just as a reminder, you specify variable name, for example x in this case, and you specify a list of values that you want this variable to take, and you specify the commands that will be performed with different values for x one by one from this list. So you start with x equal 1, you execute those commands, then you get new value for x, so in this case 2, you execute those commands, now x equals 2. You keep doing it for however many values you have in the list here, and when you are done, you finish the loop. But for loop is obviously not the only thing you want to do to break the sequence of commands in your script. The other very common thing is so-called if-then-else conditional statement. And the idea of if-then-else statement is that you have some kind of condition. For example, you check the temperature, and depending on the truth value of this condition, so if temperature is less than 32 degrees, then you do some action, and if it's bigger than 32 degrees, you do a different action. And finally, after you finish either of those branches, you are done with your if statement. So the idea of if statement is that you can choose what you are going to do depending on some pre-specified conditions. And in a lot of cases, it actually works like this, where you have two branches, one which you execute if condition is true, and the different one where condition is false. But it's also very common where you only have one branch. So you just check a particular condition, and if it's true, then you execute something. If it's false, then you don't do anything. That's a very common pattern as well. And the syntax for if looks something like this. So you start with the keyword if, then you specify the condition that you want to check. You have then, and then you list a number of commands. It can be one, it can be more commands. Those commands will only be executed if this particular condition was true. After that, you can have more branches. It doesn't have to be only two branches. You can have more conditions that you check. So you can specify elif keyword, which is basically a shortcut from else if, and that means that if this condition was fulfilled, you will execute those commands and be done with the if statement. You will basically jump all the way here. But if this condition was false, you will check here, and you will, if this condition is true, then you will execute those commands. If those are not executed, if this is not true, then you will continue checking all the other elif branches until finally you may end up with the branch called just else. And this one is always going to be true. So if neither of the previous conditions was fulfilled, then this is what you will be executing. And if any of the other ones have been fulfilled, if you executed, for example, those, then you will not execute the else branch. So here is an example of how you might want to write an if statement. Now this isn't a terribly good if statement, but it does more or less what it's supposed to be doing. So just to show you, there is something that always happens at the beginning. This is just a regular sequence of commands. And then you have the first condition. And the important thing to know is that in Bash, the conditions you are checking is just the return value of the command. So in each, as a condition, you have a command that will get executed. And whether this command was true or false, or whether the result of the condition check is true or false, depends on if the command was successful or not. So in this particular case, we have the ls command, which I hope you know. We are checking, or we are listing the file that was given as the first argument. And it may not be entirely obvious to you immediately, but it actually turns out that ls command gives you a return value which depends on whether the argument was found or not. So if this file exists, ls will exit with the success result, so with 0 value, and then this if will be fulfilled. So if there exists file with this name, the script will output first file exists. If such file doesn't exist, it will check the next condition. So it will check file given as the second argument. And again, if this file exists, ls returns successfully, it will echo second file exists. If ls fails, meaning the file does not exist, then this will not get executed, and then finally else will get executed. There is no more conditions here. If we reach this state, then else will always get executed. So then it will say no such files. And finally, after this if statement, you can of course put more commands, and those again will be executed regardless of what happens here. So this if statement will always execute one of those echo lines, never more, never less, but which one depends on the files that exist on the file system and the parameters you have given. So the idea is that you don't necessarily always want a sequence of commands. You only want to execute certain commands under particular conditions. And we have seen something very similar before. In one of the earlier lectures, I have talked about the AND operator, where you can basically combine two commands in such a way that the second one will only get executed if the first one was successful. Or the second one, you can use OR operator instead, and then the second command will be only executed if the first one was not successful. And the if statement is basically an extension of the same idea. They can sometimes be interchanged. And what you want to have is which branch to choose will depend on the return value of the condition command. So it's important to remember that the condition within the if statement is a command that will get executed, and you can put any command you want in here. We have seen ls. Here we have an example of makedir. Any command you can put there. Every single command will return some kind of value. Now, it depends on the utility if this particular command is useful or not in this kind of setup, but every single command will return a value. And the idea is that the successful execution of a command means true. So if the command was successfully executed, then we will execute the appropriate branch of the if command. And unsuccessful execution, so a return value of anything except 0, means false. Now this is a little bit tricky if you have been using programming languages before. Actually, in most programming languages, 0 means false and any other value means true. But in Bash, it originated from the successful execution and unsuccessful execution understanding. So that's why the actual value of 0 meaning true is an result of that kind of earlier decision. So here is another example of how you actually would like of a useful script which uses the if statement. Now, this doesn't look like a command to be executed, but it actually is, and I will talk about it in a second. And here is also a very, very common pattern of something you would want to be using. If the user mistypes or doesn't know what kind of arguments a particular utility should take, then it's a good idea to tell him that, well, it needs, for example, in this particular case, it needs one argument. And if you try to call this script with 0 arguments, it will complain that it doesn't know what to do if you don't provide a directory. Here is also an example of $0 usage that is reasonably useful. And the exit command, which, as the name suggests, will just exit the script, which means it will stop executing at this point and will not do anything that happens afterwards. So now the question is, what actually happens in here? So a lot of actual programming languages, they actually have the proper comparison syntax built into the language. So they have comparison operators that understand at the very least numbers and very often strings and so on. However, Bash is not one of those languages. There is no comparison directly in Bash. The only thing that you can test in the if command is the return code of something else. So what you typically do is you use external program for doing the actual tests and comparisons. And then this program will return a value which depends on whether the test or comparison was positive or not. Now, this is consistent with the design philosophy of the Bash. The idea was to keep the Bash itself simple and move as much functionality as possible to external utilities. It's not something that, well, basically the reason why modern programming languages don't do it like this is that it's just a bit too cumbersome for the user. So there will be a number of cases in which you will find Bash way of doing it pretty annoying. But that's how it works, and it's actually possible to do pretty complex stuff using this kind of technique. So it's not entirely useless. It's just that it requires a little bit more thinking and a little bit more care to make sure that you are not making some kind of syntax mistakes. So the tool you would most often be using for this purpose is user-bin test. And as the man suggests, this is a utility for checking file types and comparing values. Now, the interesting thing is that this is so commonly used that there is actually a shortcut for it. So there is, if you look carefully, you can find a file named square bracket somewhere, probably in user-bin as well. And this one is very often a link to the test command. So this is actual file name which actually gets executed when you put something like this in your script. But before we go into those details, here are some examples of how you can use test. And most often, of course, you are not using test on its own. The problem with test is that it doesn't provide any particular output. It only returns a value. So it's not necessarily clear how to figure out if test does what you want. So one easy example of testing what is the output of test is to just echo the $? Variable. So you may remember that this variable contains the return value of the last executed command. So if you do something like this, you can, of course, instead of using semicolon here, type this and then this on a new line. But the big benefit of using it in this particular way is that you can just use arrow up and get the whole thing back. So this particular line executes the test command with some kind of arguments and then prints the output, the result of the test. So in this particular test, we are testing if 1 is equal to 2, and obviously it's not. Again, 0 means successful execution, so it's true, and anything except 0 means false, so that works. And similarly, if we test if 1 is equal to 1, that works, that's the correct value. Now, you have to be very careful about spaces, because test tries to be able to test for a lot of different things. So this is just one possible invocation of test. In this particular case, there are 3 arguments, and what test expects, if there are 3 arguments, the middle one should be an operator, so in this case equality, and then test will try to apply this operator to those 2 parameters, the left one and the right one. However, in here, there is only one argument. And when test is given only one argument, it will just check if this argument is empty or not. So this argument, 1 equal 1, it's obviously not empty. So it will just return true, meaning that this is not empty. And in this case, this is what we want. But if instead we do 1 equals 2, we will still get the return value of true, which is definitely not what we wanted. So the difference between this and this is pretty significant. Similarly, this kind of operator works on strings. So if you try to test if 1 is equal to 0, 1, then you will get an answer that it's not. If you want to do numerical comparisons, you can use the equal operator, which obviously stands for equal, and then 1 and 0, 1 is actually equal. Now, the equal operator only works for numbers. So if you try to do something like this, well, test will complain that it's invalid integer. It doesn't know how to convert AA to a number. And actually it only works with numbers. It cannot really understand floats. But then the return value will be 2. So you can actually see that 0 means true, 1 means false, and then 2 means some kind of error occurred. So this is also something you can take into account. And then, as I said before, you actually have a shortcut for the test just because it's used so often. So this is perfectly equivalent to just using test 1 equal 2. And you have all the same problems as before. So this will work as you expect, this will not. If you are using test with variables, it's really important to use quotation marks if you expect those variables might be empty. I strongly suggest that you test this for different values of x and y, and especially when 1 or 2 of those are empty, to see what happens. There is also a format of test input where you have 2 arguments. So again, as we said, with 3 arguments, the middle one is operator, and left and right ones will be compared. With 1 operator, test is just checking if it's empty or not. But with 2 arguments, the first one is the operator, and then the second one is the argument. So this operator will be the unary operator. It only expects 1 argument. So for example, minus z tests if the variable is empty. Minus n tests if it's not empty. And again, investigate the difference between those 2 things. What do the quotes actually mean? Here is another example of something you may want to try, and again figure out what's the problem that can show up because of you missing the quotation marks. And the other thing that is really useful about test is that it has extensive support for working with files. So you can check if file exists by using -e and then file name. This will be true if that file exists and false otherwise. You can check if something is a directory. So this will be true if public HTML is a directory. It will be false if it doesn't exist, and also it will be false if it exists but is not a directory. And you can use -a to combine different operators. So -a stands for AND. So both left-hand side and right-hand side have to be true for the whole thing to be true. There is also -o, which stands for OR, where only one of those have to be true, and so on. So you can make pretty complicated conditions using this kind of syntax. Now, it's really, really easy to make mistakes in this syntax, so pay extra attention that you don't miss, for example, spaces, quotation marks, and so on. So here are some examples of test. One possible simple script like this, which in general just tests if the given variable is not empty. And you can use, as you can see here, any kind of variable. Now this one is potentially a bit difficult to test. You have to figure out how to make sure that the variable x you define in your, for example, command line shell will be available to this script. And as a hint, I was talking about it on last lecture. Now if you just want to test the script, you can easily replace it with $1 and then pass different parameters to see what happens. And I would definitely suggest you test those 3 options and figure out what happens. As always, the quotation marks are what makes things either work or don't work. And the important thing is to understand why one of those is correct and the other ones are not. More examples of test. Again, this one doesn't work. This is a perfectly valid string and it's obviously not the same thing as 2. This one works. In case you don't remember the arithmetics operations, so this double parentheses thing basically tells shell to evaluate whatever is inside here, and then it compares the result with this result, with the 2, and this is obviously equal. Now again, it's important to remember that this does string comparisons, so if you had 0, 2 in here, it wouldn't work. So again, test is just a command for comparing things. It is called with arguments as all other commands, and on its own, it does not understand arithmetics. Arithmetics have to be done somewhere else, for example in shell, or using external programs, like there is BC, the calculator which I talked about, there is the expr, which is a program for calculating expressions, and the spaces is the critical thing. Again, in a lot of cases, things don't work properly if you don't do the spaces that are necessary. That's the general idea behind it. I have talked about command substitutions before, so I will not go into details again, but it's important that you remember how this works and also how you can combine this with things that we have been just talking about. So, for example, you can get a number of files in a particular directory, and you can calculate expression based on, for example, number of the first parameter that was given to a script, put those 2 things in 2 different variables, and then you can use if to compare those 2 variables and print something depending on what happens here. It's also possible to use more complex examples. So here are 2 scripts which combine things in a slightly different way. So again, the for loop, which you should be familiar with, taking into account all the files in a given directory. And then in here you have the test command, this time with complex operators, so combining 2 operators using the AND. And then you have second command, again using the AND operator on the bash level. So it's important to remember that there is a difference between this and this, even though they are both related, because both have the semantics of the classical AND logical operation, but they are used in different contexts, so it matters what will actually happen. And this one is basically just a different way of writing an if statement. You could write this script by replacing this with an if. So it might be an interesting exercise again for you to try to do it. But the general idea is that you check for a file if there is both a file with a given name and a file which looks like the corresponding source code, and if there is, you remove the compiled file. That's the idea of the script. And here is a different way of using the same thing. Now it uses a even more complex thing. So here is a pipe, and this one basically shows you that for loop, the whole thing is also a command that is treated as a single complex command by bash. So you can take the whole output from the for loop and pipe it, for example, to xargs thing. So those are a little bit more complex scripts, but they show some of the interesting aspects of how the shell actually operates and how you can combine a lot of different things together. Here is another slightly more complicated example. This one actually uses a special variable called ifs, which you can definitely figure out what it does by reading documentation and trying to figure out what is the idea behind this script. And also, while we are talking about variables, it's important to remember that variable substitution is basically the first thing that happens. So you can have variable which has value ls and another variable which has value ls flags, and then you can combine those three things together into a fully functional command. And this is actually a pretty common pattern when you are looking at existing scripts in the Linux operating system. This is something that happens pretty often because of how diverse different distributions are. The same command may have different names or slightly different flags depending on individual configurations. So it's pretty common that you start your script by figuring out, so how is called ls command? And this is obviously not terribly useful thing to do because ls is almost always called ls. But for less obvious commands, this is something that you can do. So you can start by trying to figure out, so how is the command I need actually called? What kind of arguments should I pass to get the behavior I need? And then afterwards, in the main body of your script, instead of using ls, you just use the variable, and then it allows you to make a script which is much more portable because it's much easier to adapt it to your particular system. Besides for loops, there are some other ones, because for doesn't allow you to do some of the pretty important things. Basically, in for loop, you have to know a priori, before you start, you have to know how many iterations you want. And that's not something that is always the case. Sometimes you want to figure out how long are you going to do your loop while you are doing it. And there are two flavors of those kinds of loops. There is the repeat until loop and do while loop. And they both have a similar structure, just with minor differences. So repeat until loop, you define your commands, and then after you have done the command, you check some kind of condition. And if condition is true, you are done. That's all. And if condition is false, then you do your tasks again. So we'd basically continue looping through this until the condition becomes true. And the idea is, of course, that the task that you are doing here should at some point make this condition true. Otherwise, your loop will go infinitely. And the dual loop is called while, where you start somewhere, you check the condition first, and if the condition is false, you just finish. If the condition is true, you do the task, and then you check the condition again, and so on. You will continue doing this until you finish, until the condition becomes false, and then you will finish. So here is an example of how that might work. And again, the condition within the loop is exactly the same as the condition in the if statement. So you are still using the test command, or the shortened version of test command. So in here, you are checking if a particular file exists, and this is the negation. So you are basically, you will continue sleeping while the file does not exist, and then as soon as it appears on the file system, you will be done with the loop, and then you will print the result. And similarly, you can use while loops to do counting. So you start with x equals 0, and you will continue executing this while x is less or equal 20. So you will print 0, and then you will increase x by 1. So you will print 1, you will increase x, you will print 2, and so on, all the way to 20. There is one more important pattern that you can do with while loops. So, for example, if you want to do something to all the arguments to your script, what you can do is you can do what you want to do to the first one. So in this case, we are just doing echo, but you can do whatever you want. And then you can call shift. So what shift does, it moves all the arguments by one position to the left. So it discards $1. The idea is that you have already done whatever you wanted with $1, so you don't need it anymore. $2 becomes $1, $3 becomes $2, and so on. So after doing shift, you come back here, you do something to the new value of $1. So this is what was originally second argument, but now you can still operate on it using $1. And then you do shift and so on. So this allows you to operate on all the arguments regardless of how many there are. And you basically do it until you run out of arguments, so until the argument becomes empty. And again, important thing, quotation marks, so this and this will not necessarily work the same. You can also use while without any condition, so with empty condition. This will be so-called infinite loop, so this will continue running forever, well, basically until you press Ctrl C. It's sometimes useful to do something like this. Well, obviously not just with echo, but having scripts that never end, that will do whatever they are supposed to be doing forever, is useful. There are functions that you can define, and basically functions are named pieces of code. So you just, it's like mini scripts. You define the function once, and then you can use it multiple times. So if you are using the same piece of code many times, not necessarily in such a way that you can easily do it into a loop, but you are executing the same code in multiple contexts, sometimes it's useful to define it as a function. And functions can also take arguments, so you can do define function print, which will echo the first argument, and then you can use it using print hello, print word, things like that. If you want to have user interactions, the obvious case is to do parameters, so $1, $2, and then when the user calls your script, they will pass arguments that they want. But sometimes you want to have interactions while your script is working. So one possibility is the select command, which will print a very simple menu and allow the user to choose a value from it. You can also read, for example, a command from the user or something like this. And finally, arrays are slightly better ways of having multiple values than just regular strings with spaces as dividers. Because the idea is that arrays get around a lot of problems with spaces and quotation marks and so on. We will not look into arrays too much in the course, but they are important to know about. And again, critical thing to remember is about positional variables, how to operate with them, because this is the main focus of the interactions with the user. This is where most of your information will be coming from, and what your script does in most cases will depend on the arguments. So $1 to $9, shift is very, very important, and so on. Those are things that I have already talked about. File name matching, again, something to remember, both when you want to be using it and when you don't want to be using it, to make sure that those kinds of characters don't catch you by surprise. And if we look at some examples of actually existing bash scripts on the Linux file system, there is a number of scripts that are, for example, executed at boot up, like rc local. when you are logging into the system, there is a number of scripts that get executed. Every time you create a new shell, there are some configuration scripts that are executed. When you log out, scripts are executed, and so on. And most of them are originating from etc scale, which is the kind of default values for those scripts. But you can modify them, so you can adapt them to your needs. And some of them are pretty complex, some of them are very simple. So it's a good idea to take a look at them, try to see how it works, maybe add a command or two to see if it actually does what you expect it to be doing. One example is the path variable, where the book says that the tilde/bin is automatically added to user's path variable, but if you just do echo path, it won't appear. So here is one example of where scripting is useful to figure out actually what the book is talking about, because it doesn't seem to be true, but actually it is. Depends on if the directory actually exists or not. And etc rclocal is one of the important scripts. So those are the scripts that you will probably be modifying from time to time. Now this script is kind of funny because it's almost never the correct place to put things. Every time you have a configuration, there is almost certainly a better place to put this configuration modification or logging information or something like this. But if you are trying things out, this one is probably the easiest. This is the place where you can put a lot of this information and it will work. So this is definitely something to remember. And we talked a lot about bash scripting, but bash is definitely not the only scripting language. It's good for simple administration tasks because it's a high-level language. It's really easy to execute external programs. So most of the administration task is actually executing programs in appropriate order with appropriate parameters. There is no compilation and there is pretty easy to interactively debug. So you type a command, see if it works. If it does, you just put it in a file. This kind of things makes it really easy to start with something, with basically a process that you know, something that you are already doing, and start automating it step by step. Now, for more complex programs, it doesn't really work. The syntax is pretty bad, and it's really easy to make mistakes. Even if we forget about things like low efficiency, which may or may not matter, the programming effort in actually writing complex things in bash is pretty significant. So there is a number of other alternatives. So one which is potentially interesting to know is the language called avk, which is designed for processing of semi-formatted text. So this one is actually often used within bash scripting, just for working with text. So this one can be useful to learn. Perl is probably something you have heard about. It's a high-level general-purpose language. It's from the late 80s. And it's basically designed as a combination of C language with bash scripts. And it should sound terrible. But it was popular. It was actually very popular at some period of time because it was one of the first such scripts. But since then, it kind of faded in popularity. It's still used in some contexts, but most cases there are better languages for doing things. The best one, of course, is Python. So this is the one that I like. And to be honest, there is a number of alternatives, but I like Python. One of the big benefits of Python is that the high focus on readability. So it's often called executable pseudocode. So it's really easy to understand what Python does. And this particular example may not be the best case of this, but it shows you what's possible. A pretty complex algorithm can be coded really succinctly in Python. And the biggest draw to Python is probably the huge standard library. So there are existing modules for a lot of functionality. And if you are thinking about programming, then your next thing to consider is definitely text editor. So you have to figure out some text editor which is good for you, which you like, and which is powerful enough to support what you need. The important things are flexible, so you really want it to be usable in many situations. One of the issues is that if you are only programming, for example, in C, then you can find the best editor or environment for C and be happy with it. But in most cases, you will end up working with multiple languages, and then you want your text editor to be able to support all of them. And that's not as easy to figure out as it sounds. You want it to be customizable, so you want to be able to adapt it to your particular needs. And obviously you want it feature rich, so Notepad is not the best solution. You want things like syntax highlighting, auto-indentation, search and replace, code templates, a lot of pretty cool features that some of the more complex editors have. And two editors I wanted to very briefly mention are VI, which is modal text editor, which is probably the only of its kind, so it's definitely not intuitive, but it allows you to operate in two different modes. One in which you insert text, so where the letters actually do what's printed on them, so they add letters to your text, and in command mode, where each letter is assigned a particular command. So that's a lot of commands that can do pretty powerful things. And here is a very basic introduction to VI. And the other I wanted to talk about is Emacs. So the benefit of Emacs is that it's possible to customize almost everything about this editor using language called Lisp, which is one of the more powerful programming languages. It's very flexible, and it has a lot of additional modes for doing things. So it has built-in file manager, calendar, calculator, email, web browser, a lot of things. So here is the very basic introduction. Both VI and Emacs actually have interactive tutorials, so it's really easy to use them. And there are some pretty advanced programming features that you may be using in both Emacs and VI. And that's it for today. Thank you very much, and I will see you on the lecture.